Okay, so this is page 3 and 4. Consider these sets, and let's see. The easiest thing to do first is just to write out what each of these sets is equal to. So x is a number, an integer between 2 and 5, not including 5, so that would be 2, 3, 4. Here, x is an integer between 0 and 5, not including 0, so that'd be 1, 2, 3, 4, 5. P would be a positive integer between negative 2 and 6, not including 6, so that would be not negative 2, not negative 1, because it's a positive integer, not 0, because it's a positive integer. 1, 2, 3, 4, 5. And then S would be any number, any coordinate pair x, y that is on the line x plus y equals 5. X and y being positive integers, so that could be 1, 4. That could be 4, 1. That could be 2, 3. That could be 3, 2. And then T would be coordinate pairs, and it's the same thing except for this time it's all integers. So that could be um, many coordinate pairs. I mean, you would have everything that you have right here, plus you would have like all the zero combinations, negative combinations. You could have 0, comma 5. You could have 5, comma 0. You could have negative 1, 6. So that list would go on forever, right? P is a prime number and a multiple of 4. Well, there are no prime numbers at a multiple of 4, so that would be empty set. W, x is a factor of 20, so that would be 1, 2, 4, 5, 10, and 20. And the last one is any real number less than 200. Well, that's like, a really big set. Pretty much any number, right? Up to 200. So the 199, 2 2/3, pi, okay, all these. There's an infinite number of numbers. Okay, state whether each statement is true or false. So let's see, and means proper subset. So a proper subset, remember, does not include, it can't be the empty set. The empty set and the set itself are not proper subsets of any set. So when we have this notation where it just looks like that with no underline under it, that means it's a proper subset. So it has to be something that is smaller than the set. So for example, this n has to be smaller than m. Let's see if it is. Well, n is definitely not smaller than m. It's got a 5 in it, so that's false, right? What about s is a proper subset of t? Is that true? Yeah, because everything in s is also in t, so that's true. P is a proper subset of M. Is that true? Let's see. Well, P is equal to M. Oh no, I'm sorry. P and M. So P is actually bigger than M, so that's false. W is a proper subset of X. Yeah, because look, W just has these like 6 numbers in it. X has like every number possible under 200, so that's true. What about M is a proper subset of P? Um, M has 2, 3, 4. P has 1, 2, 3, 4, 5. So yeah, that's true. Okay? That wasn't too bad, right? Let's do this last one. V is a proper subset of W. Well, V is the empty set. And the empty set, remember, is not a proper subset of any set. So this is false. And this would also be false because, remember, empty set is not a proper subset of any set. Okay. List all the subsets of these sets. So for example, there's all the subsets of the set with A in it would just be empty set and A. And AB would be the empty set and the set itself, AB. And then it would also be the sets with A and B in it separately. Okay? And then ABC, that would be empty set, the set itself, ABC. and then that would also be A, B, and C. And it would also be A, B, and B, C, and A, C. And it would also be A, B, C. It would also be A, oh, I went too far. I'm doing the wrong one. I was doing this one, right? And then, so that would be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. That would be 8. Okay, so let's see. There is, so we found 2 subsets here. We found 4 subsets here. We found 8 subsets here. How many do you think are going to be here? 2, 4, 8, 16, right? How many subsets does a set with n members have? Well, the pattern here is one element yields 2 subsets. 2 elements yields 4 subsets. 3 yields 8, and 4 yields 16. The relationship here is 2 to the n, right? Because you just take 2 to the power of n, and then that gives you how many subsets there are. How many subsets does A, B, C, D, E, F have? Okay, so this is 6. So if it's 6, that would be 2 to the 6th, which is 16 times 2 times 2, which would be 64, I think. A set has 128 subsets. How many elements are in this? Okay, so that would be 2 to the n equals 128. Well, we know that 2 to the 6th equals 64, so 2 to the 7th is equal to 128, so n equals 7. Now in the next one it says, list all the proper subsets of, and this gives A, AB, ABC, and ABCD. Now it's the exact same thing as before, except now they ask for proper subsets. Now proper subsets are sets are more strict than subsets, because subsets can also include the empty set and the set itself, but the proper subsets don't. So remember how we said that the subsets of A included the empty set and the set itself? Well, here there's nothing. Okay, nothing is a proper subset of an element with just one, with a set with just one element. What about AB? AB, there are 4 elements here, but 2 of them are legal. This one and this one. So what's left? Just 2. What about ABC? In ABC, there's 8 elements, but again, 2 of them are illegal. The empty set and the set itself are illegal. So that means there's only 6 left. And so the pattern here is, whatever number you had here, you got to subtract off 2. Okay? So 2 minus 2 is 0. 4 minus 2 is 2. 8 minus 2 is 6. 16 minus 2 is 14. How many proper subsets does the set with n members have? 2 to the n minus 2. How many proper subsets has A, B, C, D, E, F? Well, up here it said 64, so 64 minus 2 is 62. A set has 254 subsets. How many elements are in this? Okay, 254 subsets. So that means it had 256 to the n is 256, because this is minus 2, right? How many elements are in here? So what's n here? N would be 8, right? Because it's 128 times 2. Okay. The intersection of set M and N is the region between M and N. Okay. The union of the sets M and N, that means like everything in M plus everything in N, so it'd be kind of like that. The complement of set M, denoted as M apostrophe, is the set of all elements in the set that do not lie in M. So that would be, everything around M. Okay. Now we're going to do a few more specific problems like this. So I'll do just some random ones here. Okay, let's do this one. So E. We'll do the complement of P union Q. So first we'll find uh, P union Q. Q. So that would P union Q. Okay. So union means like anything that's colored in here, red or blue. So that would be that region. And then it says not. So not would be everything that's outside of that. So that would be the outside. Okay. So the answer for E would be the region outside these two circles. Okay. Let's do this one. Okay. So we have P intersect Q. So P intersect Q. So that would be this region here, the fish-shaped region. And then it says not. So not would be everything besides the fish region. It would be that, right? So this was F, so I'm going to color in. Well, actually, it's everything except for the fish region, so it would be like that, right? Okay. All right. Now let's do a couple of these for H and N. So we'll do like this one here. So E. So not H intersected with not N. Okay, so let's say not H would be everything outside of this region, H. And then not N would be anything outside of this region, N. So they want the intersection for that. So where is there red and blue? That would be the outside of H, right? Okay. Let's see. Shade the region that represents. Let's do like this one here. Okay. So let's see. Not W. Not W. All that. And then intersected with R. R is this smaller circle. And so that would be this region, right? But then it says not that. So not that would be everything except for that circle, right? So it would be this green region here. It would be everything except for R. Okay. Let's see. And then number 4, U is defined as a set of all integers. Consider the following sets. And I didn't ask you to do all of these, but we'll just do a few. So we'll do like that one, we'll do that one, and we'll do that one. Okay? So let's see, we need to do A, B, C, D, and E. So let's expand B here. B is any number between 0 and 5 that's an integer, not including 5. So that would be 0, 1, 2, 3, 4. C is any prime number, so that would be even prime number, so that would be 2. And actually that's it, because there's no other even prime numbers besides 2. D, 4, 5, 6, 7, and E, a square number less than 50, so that would be 1. It would be, I don't know, 0, 0, 1, 4, 9, 16, 25, 36, 49. Okay? Okay, so A intersect with B. So that would be 1, 2, 3, 4, 5 intersect with B 0, 1, 2, 3, 4. So which numbers do they have in common here? It would be 1, 2, 3, 4. Okay? C union with D. So you would combine C with D. So that would be 2, comma 4, comma 5, comma 6, comma 7. C intersect with D. Okay, C intersect with D. So that would be like which numbers are common between these two? Nothing. Okay. And then is empty set a proper subset of E? And remember, an empty set is not a proper subset of any set, so no, that would be false.